Okay, in this video, we're just going to focus on identifying the domain and the range of a piecewise function. Okay, so we're going to focus here. So if we look right here, we have two pieces. F of x is equal to this piecewise function. It's got the bracer here, and it's got two pieces. Okay, this first piece here is used when x is less than 4. This piece here, the second piece, is used when x is greater than 4. Notice that there is no place when x is equal to 4. This does not say equal to 4, and this does not say equal to 4. Therefore, if we were to say, well, what is f of 4? We would have to say does not exist, because 4 cannot be plugged into either one of these pieces. So 4 is not on the domain of this function, and we can see that by identifying the domain. The domain of the first piece is all x values less than 4. That's negative infinity up to 4, but without a bracket. It's a parenthesis. This piece here is all x values greater than 4. So the domain of the second piece is going to start at 4 with a parenthesis and go up to infinity. And so if we wanted to identify the domain of the overall function, the domain of f of x is going to be negative infinity up to 4 union 4 up to infinity. Notice when we do this, when we do the 4 with the parentheses on both sides and the union, it means that 4 is not included. That means x cannot equal 4, okay? And so that's important to notice when we do the domain. So to do the domain, all you have to do is identify the domain of each of the pieces and then union them together. And we'll see what happens if they meet up. If there's no gap, then we can just make it negative infinity to positive infinity. But that did not happen here. We're missing 4, okay? All right, now let's identify the range of this piecewise function. Okay, so to identify the range of one of the pieces, so if we want the range of piece 1, let me erase this here. To identify the range of piece 1, we're going to start by identifying the edge. I call it the edge. We're going to plug in 4 into this. So 2 times 4 plus 5 is equal to 8 plus 5, which is equal to 13, okay? Now, because the domain does not include 4, we are also not going to include 13. So the range is either going to be negative infinity up to 13, or it's going to be 13 up to infinity, okay? And the way that we determine which of the two it is we're going to take a test number. We're going to select a number on the domain, something less than 4, like 3. 3 is less than 4. And if I plug 3 in, 2 times 3 is 6, and 6 plus 5 is 11, okay? And so I have to decide, is 11 on this, or is 11 on this range? It's only on one of them. It's not going to be on both of them. Well, 11 is not between 13 and infinity. 11 is between negative infinity and 13, and therefore this is the range of this piece right here, okay? So we're going to go ahead and erase the rest of this, and we're going to say that the range of piece 1 is negative infinity up to 13. Negative infinity up to 13, okay? Now we need the range of piece 2. We're going to do the same thing. We're going to plug 4 in here. 3 times 4 is 12. 12 plus 7 is 19, okay? And so it's either going to be negative infinity up to 19, or it's going to be 19 up to infinity. It can only be one of those two. So we're going to pick a number that is larger than 4. Let's say 5. 5 is larger than 4. And so we're going to plug 5 in. 3 times 5. Let me just do that right here. So 3 times 5 plus 7. 3 times 5 is 15. 15 plus 7 is 22. 22 is not on this piece. 22 is on this piece. And therefore, the range of the second piece is 19 up to infinity. And so now when we want to identify the range of this piecewise function is going to be negative infinity up to 13, which is this one right here, union 19 up to infinity. 19 up to infinity. And since there's no overlap here, okay, all of these numbers, negative infinity up to 13, are smaller than 19 because there's no overlap. We're not going to modify this. This is the final answer. This is the range of this function, okay? Let's do another example. Okay, so here's another piecewise function. This one has a linear and a quadratic, okay? Now, the fact that there's a quadratic means that it's a little complicated because we have to determine, we want to make sure that we get the range correct on a quadratic. And remember, we learned how to identify the range of a quadratic, okay, by using negative b over 2a, which identifies the vertex. So let's identify the domain of each of these pieces first. The domain of piece 1 is all x values that are less than 6 but also equal to 6. And so the domain is going to be negative infinity up to 6, but it's going to include 6, so we're going to put a bracket. The domain of the second piece is all x values greater than 6. So that's going to start at 6 and it's going to go up to infinity. And when we combine these two together, when we union this with this one includes 6 and this one starts at 6. Therefore, the domain of this whole function is actually negative infinity up to infinity. It includes every number, okay? So that was easy. Now let's identify the range of each of these pieces. Okay, to identify the range here, the range of the first piece, remember to find the range, first we're going to have to plug in this number. So we're going to plug in 6. 6 squared is 36. 12 times 6 is 72. So 36 minus 72. 36 minus 72 is equal to negative 36, okay? But we also have to find out, because it's a quadratic, so one possibility is going to be negative infinity up to negative 36, or another possibility is going to be negative 36 up to infinity, okay? But there's actually a third possibility because this is a quadratic. We're going to have to do negative b over 2a and find the vertex x value. Okay, this is important because it's a part of finding the range of a quadratic. Well, b in this case is negative 12 and a is 1. And so we're going to go negative 12 over 2 times a, which is 1. And we wind up with 12 over 2, which is equal to 6. Well, that's what we have. That means that this is the vertex. That means that this 6 right here is the vertex. And because it's the vertex, and this is an upward opening quadratic, that means that this is a minimum. And since this is a minimum, then it must be this one right here, negative 36 up to infinity. See, what I was about to write here is or negative 36 up to infinity. So these are the three choices. And since we know that this is the range of this quadratic, it has to be the negative 36 up to infinity. And therefore, the range for this first piece is negative 36 up to infinity, okay? And all we're doing there is we're applying what we learned about the range of a quadratic from a previous lesson, okay? All right, now we need the range of the second piece here. We need the range of piece 2, range of piece 2, okay? And so that's going to be the range of x minus 30. We're going to plug in 6. 6 minus 30 is equal to negative 24. And therefore, the range is either negative infinity up to negative 24, or it's going to be negative 24 up to infinity. And we're going to take a test value. We're going to take something larger than 6, like 7. Well, 7 minus 30 is equal to negative 23, okay? And negative 23 is not on this piece. Negative 23 is on this piece. And therefore, the range here is going to be negative 24 up to infinity. Well, I want you to notice that negative 24 up to infinity, if we were to union this with this whole thing is inside of here, okay? Because negative 24 is in the middle of here, and they both go to infinity. And therefore, if we were to union these two together, if we were to say negative 36 up to infinity union negative 24 up to infinity, well, that's the same thing as negative 36 up to infinity. This negative 36 up to infinity includes this entire interval. This interval is inside of this interval, and therefore this is just the answer. And therefore the range of this particular piecewise function is negative 36 up to infinity. Okay, I think we should try just one more example. Okay, so here we have a piecewise function g of x, and the first piece is negative 5 minus 2x, and the second piece is 4x minus 11. Okay, now I want you to notice that they're both linear. This is x to the first power. This is also x to the first power. This is negative 2x to the first power. That means that this has a negative slope, and this is positive 4x, so this has a positive slope. And then the domain for the first piece is all x values that are less than or equal to negative 3, and the domain for the second piece is all x values that are greater than or equal to 2. Now I want you to notice that these do not meet up. There are a bunch of numbers that are left out of this domain, and we're going to see that right now. For example, 0. 0 is not less than or equal to negative 3. 0 is also not greater than or equal to 2. Therefore, 0 is not on the domain. So if we were asked in this case, what is g of 0, the answer would be DNE, does not exist, because 0 is not defined for this piecewise function. 1, positive 1 and negative 1, neither one of them are defined on this piecewise function either. Okay, so if we wanted to identify the domain and range, we want to identify the domain of the first piece, which is all numbers x values less than or equal to negative 3. So that would be negative infinity and up to negative 3, including negative 3, so we're going to put a bracket. The domain of the second piece is all x values greater than or equal to 2. So we're going to start at 2, including 2, so we put a bracket, and we're going to go up to infinity. And so to identify the domain of the entire function, basically we just union both of these together. So the domain of the entire function is going to be negative infinity up to negative 3, bracket, union, bracket, 2 up to infinity, and that's the domain of this whole piecewise function. Now let's identify the range of this piecewise function. To do that, we're going to identify the range of each piece. The range of piece 1, we're going to take negative 5 minus 2x, and we're going to plug in negative 3. If we plug in negative 3, we get negative 5 minus 2 times negative 3. Well, negative 2 times negative 3 is positive 6, and negative 5 plus 6 is 1, okay? And so we know that the range, it's either going to be negative infinity up to 1, or it's going to be 1 up to infinity. And we can find out by plugging in a number smaller than negative 3. Like if we plug in negative 4. Well, if we do negative 5 minus 2 times negative 4, well, negative 2 times negative 4 is positive 8. Negative 5 plus 8 is equal to 3. And 3 is on this piece right here, not on this piece right here. And therefore, the range of this piece is 1 to infinity. Okay? Now let's identify the range of the second piece. All right. The range of the second piece, we're going to do the same thing. We're going to go ahead and plug in the 2. 4 times 2 minus 11. 4 times 2 is 8. 8 minus 11 is negative 3. And so we know that it's either going to be negative infinity up to negative 3, or it's going to be negative 3 up to infinity. Let's find out which one it is. Well, I can tell you right away, because this is positively sloped, that it's going to be this one, negative 3 to infinity. But let's prove it. Let's pick a number larger than 2, like 3, and we'll plug that in. Okay? So 4 times 3 minus 11. 4 times 3 is 12. 12 minus 11 is 1. And 1 is not on this interval, and it is on this interval. And therefore, the range of the second piece runs from negative 3 up to infinity. And now what we're going to do is we're going to combine these two. We're going to combine 1 to infinity with negative 3 to infinity. But look, 1 through infinity, this whole range is included on this interval. It's included between negative 3 and infinity. Therefore, the range is just simply going to be negative 3 up to infinity. Okay? And there's 3 examples of how to identify the domain and range of a piecewise function.